Close your eyes. Go ahead, I'll wait for you. And imagine the sun. Take a mental image. And in 3, 2, 1, open your eyes. What did you see? Maybe you saw your favorite sunset, or a day at the beach with the sun overhead in a cloudless sky. If you were one of the 200 million people in the United States to see the August 2017 total solar eclipse, perhaps you envisioned something like this. Total solar eclipses occur when the moon passes directly between the sun and the Earth, perfectly blocking out the light from the sun's surface. This allows us, for the briefest of moments, to capture a glimpse of the sun's outermost atmosphere called the corona with the naked eye. This was my second eclipse. I saw my first in 1994 when I was 9 years old, outside during recess. Where I grew up in southern Indiana, the moon only blocked 85% of the sun's light on that day in '94. But it was enough for the playground lights to turn on and the birds to stop chirping. This was my first true, memorable solar experience, and it embedded within me a lifelong passion for astronomy. From my childhood backyard, I could see all the constellations, made up of the brightest stars in our night sky. Then one night, I had a revelation. I realized that each one of these stars is another sun. In fact, our own Milky Way galaxy, this cloudy streak in the darkest skies, is packed with 400 billion other stars, of which our sun is but one. In the grand scheme of our galaxy, our sun is actually a relatively average, unremarkable star. But we live with this star, and it is our personal and global connections with the sun that make it so important to us. We all have a unique relationship with the sun. Now, 25 years after my first solar eclipse, mine is as a solar physicist. My 6-year-old nephew knows that I'm a solar scientist, and he recently drew for me this beautiful portrait of the sun. He imagines the sun as a glowing circle against a blue sky. He draws rays of sunshine that warm him up on a chilly day. Maybe what he doesn't think about, though, what most of us don't think about, is the fact that the sun could be anything more than this seemingly serene, unchanging orb that literally defines our days. In the early 1600s, a new invention, the telescope, entirely changed our understanding of the sun. Astronomers naturally turned their gaze toward our nearest star, seeing it up close for the very first time. The astronomer Galileo found not a perfect sphere, but rather a collection of dark spots, blemishes on the sun's surface typically as large as the Earth. We now, very creatively on our part, refer to these regions as sunspots. Galileo noticed that sunspots are constantly changing in shape, size, location, and number. Today we know that sunspots are areas of intense magnetism on the solar surface. Another revelation came when we began to observe the sun in wavelengths or colors of light invisible to our human eyes. These observations revealed a richness beyond what Galileo could possibly imagine. The sun holds even more secrets than meets the eye. Here, in ultraviolet wavelengths of light, well beyond the color violet, we find giant arches of hot, glowing gas extended above the sun's surface. This hot gas is stuck along loops of magnetic field attached to the sun's surface exactly within the sunspots themselves. On occasion, these magnetic loops become twisted and stretch so strongly that they snap like rubber bands and break off from the sun. These solar storms send tangled clouds of magnetic field and hot solar particles into space in massive explosions, with energies equivalent to millions of hydrogen bombs going off at one time. So, That sounds pretty extreme, right? But with these volatile events also comes beauty. When solar storms reach the Earth, they are responsible for the beautiful, intense aurora, the northern and southern lights. This is a view of the aurora from the International Space Station, the aurora dancing in the Earth's upper atmosphere over the Pacific Northwest. All the while, these same solar storms can expose astronauts to high levels of radiation and can disrupt navigation systems and satellites in orbit. One solar storm in 1989 was so powerful that it caused a power failure across the province of Quebec, Canada, for 9 hours. In 2012, one of the strongest solar storms ever recorded narrowly missed hitting our planet. Let's say that a solar storm strikes the Earth right now. Imagine a world without GPS, an entire continent without electricity, hours and even days without internet, no social media, but also, hey, no work email. In our increasingly technological society, understanding our global relationship with the sun is even more important. We want to predict all aspects of our sun's magnetic behavior many years into the future, so we can better protect our technological world. But it turns out this is a really hard thing to do. Why is it so difficult? After all, we can see so many details about our sun not yet accessible to us on other stars. One reason is because the sun's magnetic fields are created deep in its interior, in its turbulent magnetic furnace. Even with the most sophisticated telescopes, we cannot peek into the sun to observe these magnetic fields being created. So instead, we turn to the next best thing, computer simulations. This is how I imagine the sun today, somewhat different from my nephew's representation. I use computer simulations to understand how the sun builds its magnetic fields and how that magnetism makes its way to the surface. Our simulations are telling us that the motion of the hot gas of which the sun is made can create ropes of magnetism. These magnetic ropes then rise through the sun's interior to the surface where they form sunspots, and continue to rise further where they are observed as magnetic arches, the same magnetic loops that spawn solar storms. So, the sun and its magnetism seem pretty impressive and complicated, but among all the stars in our galactic zoo, our sun is a relatively average star. For one thing, it is average in size. It seems big to us. 1.3 million other Earths could fit inside it. But there are stars hundreds of times bigger than the sun. Yet, the majority of the stars in our galaxy are the size of the sun and smaller. Let's take a look at the night sky to put this all into perspective. Here we see the brightest stars, making up the shapes of familiar constellations in the northern hemisphere. Then we start to see stars that are dimmer and dimmer, stars often too small or too far away to see with the naked eye. The yellow pinpricks of light are sun-like stars. The red pinpricks of light are called red dwarfs, stars ranging in size from 1/2 to 1/10 that of the sun. Around these distant stars, astronomers have now discovered a total of nearly 4,000 planets. And in this region of the sky, stars with known planets are circled in blue. But we estimate there may be as many as 100 billion planets in our galaxy alone. Imagine the innumerable possibilities of exotic planets orbiting unique, magnetically active stars, much different from the Sun-Earth relationship we are familiar with. So that begs the question, how unique is our sun's magnetism and our Sun-Earth connection? To give you an example, let's visit the nearest magnetically active star beyond our sun, Proxima Centauri. Zipping in space at over 670 million miles per hour, the speed of light, It would take us a bit more than 4 years to arrive at our nearest stellar neighbor beyond the solar system. This red dwarf is 7 times smaller than the sun. Orbiting it, we find a rocky, Earth-sized planet at just the right distance for liquid water to exist on its surface. Because this star is so small, this just right distance, this habitable zone, is only 1/8 the distance between the sun and Mercury in our own solar system. We have so many questions about Proxima Centauri's planet. Does it have oceans, continents, perhaps even an atmosphere? And might it be habitable, capable of sustaining life? Well, maybe. If this life could survive the extreme high-energy radiation it receives from Proxima Centauri, estimated to be hundreds of times greater than the amount the Earth receives from the sun. And despite being so small, Proxima Centauri routinely belches magnetic storms that rival those of our own sun. Even though the sun might adversely impact our Earth on occasion, the nearest planet beyond our solar system has definitely got it worse. So the next time you look up into the night sky, remember, each star has a secret life. Some may be harboring worlds that seem like science fiction. Even the smallest stars may be building intense magnetic fields in their stellar furnaces that impact the very life they could be sustaining. Yes, our sun is one of 400 billion stars in our Milky Way. But what makes our star special? It is our relationship with the sun-Earth relationship. We happen to be living around our star at just the right distance to have liquid water on the Earth's surface, but far enough away that the sun's magnetic storms only impact our world on occasion. We are living around our star at just the right time. In about 5 billion years from now, our sun will enter a red giant phase. It will puff up and become so large it will engulf Mercury and Venus. The surface of the sun will get much closer to the Earth, making it too hot to be habitable. Luckily for us now, our sun has settled into its calm, middle-aged years. When our sun was younger, it was more unpredictable and spontaneous, quite like humans in that way. And it would have released stronger, more frequent magnetic storms to bombard our planet. But beyond the sun-Earth relationship, it is our shared human experience with that hot ball of gas in our sky that makes it so special. It's the star that captured my imagination as a child and the one I study today. The same star seen from space by astronauts, peeking from behind the Earth and shining through our atmosphere. The same one we can all see from around the globe and truly a driving force for our continued existence. That's why it's so important for us to continue to learn more about our sun so that we can maintain our solar connection. Thank you.